Okay, when we're working with two-step conversions, remember, our conversion factors have always been Avogadro's number, which is 6.02 times 10 to the 23 particles, is equal to 1 mole, but we also know that that 1 mole is equal to our molar mass, which is measured in grams. Now, with this being said, sometimes we like to skip the mole step. We just say, let's work directly with particles and molar mass, okay, grams to particles. Now, there are several different ways to show this in a math problem. If they ask you, for example, how many atoms are in 4.2 grams of NaCl, we would first start off with our given, exactly like we did in one step. But instead of going into moles, like we've been doing, and only using one of our factors, we're going to use both Avogadro's number and our molar mass in the same problem. Up until now, we've only used one or the other. So we're going to set up our problem the exact same way. I want 4.2 grams of NaCl is equal to X number of atoms. Okay, I create my fraction. We know that if my whatever unit I have on the top of my fraction also needs to appear at the bottom. So because I have grams on the top, I'm going to put grams on the bottom of my left side, and because I have atoms on the top over here, atoms will appear on the bottom. Now, which number goes where, and how do I know where to put things? Well, grams is represented by our molar mass. So I need to calculate the molar mass of NaCl. We've done this in several videos already, but just in case you haven't caught on yet, or maybe you haven't watched the molar mass video, molar mass is calculated by first splitting up our elements. We know that Na and Cl are separate elements on the periodic table because they both begin with a capital letter. The L and the A are both lowercase, which tells us that they are paired with the capital letter that came before it. Now, I only have one of each. I multiply them by their mass on the periodic table. Sodium is 22.99 and chlorine is 35.45. Okay, when I multiply them out, I get 22.99, 35.45, and when I add them together, and I say 22.99 plus 35.45, I will get as my answer 58.44 grams per mole. So what I'm going to do is I'm going to put that 58.44 grams right here beside my grams in my fraction. Now I need to say, okay, well, which one has atoms? Well, we know that particles can be atoms, formula units, or molecules. Really, it can be anything except for grams and moles. Okay? It can be anything. You could have 6.02 times 10 to the 23 donuts, or Sour Patch Kids, or students, or desks, or marshmallows. Atoms, formula units, it's all the same. So atoms belongs with Avogadro's number. So I'm going to put Avogadro's number right here at the bottom of my fraction. So now that I've set up my ratios, I need to cross multiply and solve for x. In order to cross multiply, I first am going to multiply this way. Now, with Avogadro's number, remember, you have to make sure you put it in your calculator correctly. And you always look at your parentheses. They're very important. So in your calculator, the way you would put it is you'd put parentheses 6.02. You should have an EE function, or perhaps one that says EXP, and then you put your exponent, which is 23, times 4.2. Now, when we do this, remember, We are always having our calculator with us in class. We're going to have 6.02 EE23 times 4.2, and we will get for our answer 2.53 times 10 to the 24th, and our units are going to be grams NaCl atoms, and we're going to set that equal to the other cross multiplication section, which would be our X number of atoms times 58.44 grams. And in order to get our atoms by themselves, we're going to need to divide on both sides by 58.44 grams. When we do this, we notice a couple of things are going to cancel out. We're going to have the whole section over here cancel out, and then our grams on the left side also cancel out. In our calculator, you're going to need to make sure that you use parentheses and your EE key or button in order to do our final calculation. We're going to put 2.53 EE24 divided by 58.44, and for our final answer, we will get 4.33 times 10 to the 22 atoms of NaCl equal to X number of atoms, which is exactly what we want. The atoms on both sides match, so we're good to go. So essentially, this is the exact same thing that we were doing, except now we're avoiding the moles. We're using both of our conversion factors at the exact same time. So same steps, just all kind of combined together.